Left your water over there.
Oh, thank you. I'm always leaving it somewhere. Ugh.
Happy Wednesday. We're going to continue trig equations. Remember, we're solving on the interval 0 to 2 pi. Well, if I have similar to one we've done before, I'm going to multiply everything by tangent. Okay, cotangent. Tangent squared minus 4 tangent plus 3 is equal to 0. Oh. Just thinking of what I want it to be. There. So we're going to let zeta be tangent of x, right? So change a variable. So it's quadratic.
Factorable. Thankfully. Are you gonna throw ones at us that need the freaking quadratic formula?
Possible. Another way of zeta, and I like this way better. Right, so it becomes what, zeta plus 1.
No, they gotta go with minus.
Zeta minus 3. Oh no, that is a minus. Looks like a plus on my notes.
Remember that video game Cuber? Because that Zeta looks like a character called Coily. The villains.
Zeta would be 1. Or zeta would be a, doesn't look like a zeta. Zeta equals 3. But zeta is tangent. Right, tan x is either 1 or tan x is 3. When is tangent of x equal to 1?
Degrees. Radians.
It's always radians.
Pi over 4. Oh, well. Did you just get the degrees and divide it by 180?
I don't care what you do as long as the answer's in radians.
How many places do you want to go to?
Has to be exact form. We already solved this. So where's tangent 1?
Oh, right. Pi over 4.
It's not the only place.
Oh, or 5 pi over 4.
Right. Or where's tangent of x equal to 3? This one we didn't do.
What, just leave it like that?
It's its exact form. One location is the inverse tangent of 3. Another location is the inverse tangent of 3 plus pi. So that's our solution set. Right? So answer should always be an exact form, unless it's specified otherwise. Cosecant x plus cotangent x equals √3.
Sine plus cosine or something.
Multiply everything through by sine. 1 plus cosine is now equal to √3 sine.
Sides.
What are you gonna have to do? And then right sine squared is 1 minus cosine squared. You have 4 cosine squared plus 2 cosine minus 2, it looks like, equal to 0. You make life easier by dividing everything out by 2. That's right, 2 cosine squared plus cosine minus 1 is equal to 0. And just to make it easier to see, change a variable, let gamma be cosine of x. That can be factored. Gamma minus 1 times gamma plus 1. Gives us 2 possible solutions, right? Gamma is a half, or gamma is -1. So cosine of x is a half, or cosine of x is -1. I probably should write it this way. Where is cosine equal to 1/2? Where else? Cosine.
Oh, no, I'm jumping ahead. 1/2. Negative pi over 3, which would be 5 pi over 3.
Right, or x is pi, because that's where cosine is -1.
So these are always going to be limited to the domain of 0 to 2 pi.
No, that's just what the instruction said for this problem set.
Oh,
However, we did a lot of manipulation. X cannot be pi.
oh, is the cosecant not defined there?
Now there's cotangent. So we can immediately now roll out pi. What about 5 pi over 3? check 5 pi over 3. That's quadrant 4. Cosecant and cotangent will both be negative there. Which means there's no way you're going to get negative root 3 out of that. So x cannot be 5 pi over 3 either. What about pi over 3? Well, the good news is they're both positive. So now just plug it in, make sure it satisfies the equation. So cosecant of pi over 3. 2 over root 3. Cotangent of pi over 3. Would be root 3? No. Be 1 over root 3. 2 over root 3 plus 1 over root 3 is 3 over root 3, which is root 3. We only have one solution. X is only pi over 3. So whenever you do any kind of manipulations on the equation, you're going to have to check. Using identities is fine. That's not going to rule out any answers, any solutions. But any kind of manipulation outside of that, you're going to have to check. So we multiply both sides by sine. We're only allowed to do that if sine is not 0. Then we squared both sides. That's how we got the 5 pi over 3.
Just to back up, when you multiply through by sine, sine cannot equal 0.
Correct. You're not allowed to get sine equals 0. Otherwise, you'd have 0 over 0. All right, so cosine minus root 3 sine is equal to 1. If that's cosine minus 1 is equal to root 3 sine. Well, now we're going to do something very similar. We're going to have to square both sides. And then right, sine squared is 1 minus cosine squared. We're going to wind up with 4 cosine squared minus 2 cosine minus 2 is equal to 0. Or 2 cosine squared minus cosine minus 1 is equal to 0. Very similar. Right, so really, it's going to be identical, just the signs flip in the previous one. But lambda be cosine. 2 lambda squared minus lambda minus 1 is 0. Two lambda plus 1 times lambda minus 1. We get lambda is negative half or lambda is 1. Where is cosine negative 1/2? Or
No, not that. Cosine negative. Four pi over.
and then cosine is 1 and 0. Zero is a solution. And cosine of 0 is 0. What about 4 pi over 3? Cosine of 4 pi over 3, we already said negative 1/2. Sine of 4 pi over 3. Negative root of 3 over 2. So you get negative 1/2 plus 3/2, which is 1. So 4 pi over 3 is a solution. What about 2 pi over 3? Negative 1/2. Sine is positive there, which will give you a negative. So 2 pi over 3 cannot be a solution. Our solution set is then 0, 4 pi over 3. 2 cosine x equals 1 minus sine x. We're going to square both sides again. Right, cosine squared is 1 minus sine squared. It's -3. 5 sine squared minus 2 sine minus 3 is equal to 0. Let chi be sine of x. Five chi squared minus 2 chi minus 3 is equal to 0. You should be familiar with chi from stat. The chi squared test.
Actually, that's stat 2.
Really?
Yeah, we didn't do chi-square, thank God.
I do it in stat 1.
Just bogged down in hypothesis testing. I feel like the brain came off the tracks in that class for me.
Chi squared is goodness of fit. That is definitely stat 1.
I mean, you can't get to everything. Look at that monster textbook of ours.
That too is multivariate. And it is in the curriculum, so I'm surprised that it wasn't covered. Oh dear.
I'll ask him about it.
I think chi squared is goodness of fit. I'm fairly certain it is.
I don't know, it might just be hidden in those formulas we're pumping into the calculator.
Might be, but hey, it's chi squared test.
Full factoring. You gotta give us ones that can be factored.
So this can be factored. Five chi plus 3. And then chi minus 1. Right, so chi is negative 3/5. Or chi is 1. This means sine of x is negative 3/5. Or sine of x is equal to 1. That would be x. When I'm looking at negative 3/5. That's the easiest one, so that's the one I'm going to do first. Right? You can't just put inverse sine of negative 3/5. Because that does not give you a value between 0 and 2 pi. Gives you something between minus pi over 2 and pi over 2. Two pi plus inverse sine of negative 3/5. There's one solution.
Sorry.
Similar angles, that angle's also x. That's another solution. We're going to want that. This is what we have. Which, by the way, is this, right? So that is what we have. The way that's written. Pi minus the inverse sine of negative 3/5.
Can you explain again? You were saying that. Oh, God. So, all right, the sine is only, how did you say it? Something about the negative pi over 2 to pi over 2.
What's the range of inverse sine? Negative pi over 2 to pi over 2.
In quadrants 4 and 1.
Yes. We want our answers between 0 and 2 pi. This is not between 0 and 2 pi if you take the inverse sine. This is going to give you a value between minus pi over 2 and 0. Because the range is minus pi over 2 to pi over 2. So you have to add 2 pi to it to get it between 0 and 2 pi.
So one of them, there would be an arc going even further around the L and one back to X, right?
Yes. Right. So the solution we want is that.
Okay. You don't have it exactly pi over something for the.
Sine, inverse sine of negative 3/5, that is its exact form.
The sine X one's easy enough. Just pi over 2.
Or x is pi over 2. Now comes the fun part. We square both sides. That means we have to check. Pi over 2 is simple enough. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. You get 0 equals 1 minus 1, which is true. So pi over 2 is a solution. Pi minus the inverse sine of negative 3/5.
Is a difference formula.
So cosine will be negative because it's quadrant 3. Sine is negative because it's quadrant 3. That can't be right. You get negative equals 1 plus something. So you're saying negative is positive, which is not true. So that's not a solution.
So you just focus on the quadrant.
Not just.
Well,
Well, here you can because you're going to get negative equals positive, so you're done. You know that can't be true. 2 pi plus the inverse sine of negative 3/5. Cosine's positive. Sine is negative. You're going to get positive equals positive. So that could be a solution. You just have to verify it. And in fact, if you plug it in, it is a solution. The easiest way to verify its solution by hand is just to ignore the 2 pi plus. Just look at inverse sine of negative 3/5. Because they give you the same thing. Because it's 2 pi periodic.
Yeah.
There'll be 1 minus negative 3/5, right? 1 plus 3/5, that is 8/5. Then you just have to determine what is the cosine of the inverse sine of negative 3/5. Well, it's a 3, 4, 5 right triangle. Cosine would be 4/5. 2 times 4/5 is 8/5. 8/5 equals 8/5. That's a solution. So there's your solution set. Pi over 2, 2 pi plus inverse sine is negative 3/5.
So the third quadrant one didn't work.
Wouldn't work. You'll get negative equals positive, which can't happen. Right? That's why I don't have to even bother plugging it in to verify, because you know just from analyzing it, you're going to get a negative number equals a positive number. Look at the fourth quadrant when you get positive equals positive. That's not enough to say it's a solution. You have to actually verify it, and I just did that. You'll wind up with 8/5 equals 8/5, so it's a solution. Those were the moderate difficult ones. Now we get into the tricky ones. All the ones we looked at, all of the trig functions were of x. What if it's more than x? I'll start off with some simple ones first, and then obviously they'll get progressively more difficult. Sine of 3x equals negative root 2 over 2. Remember, we want solutions between 0 and 2 pi. That means 3x has to be between 0 and 6 pi. This is a note. So treat 3x like theta. If sine of 3x has to be negative root 2 over 2, then what does 3x have to be? In other words, where is sine negative root 2 over 2?
Pi over 3. No. 3 pi over 2. No, damn it.
5 pi over 4 and 7 pi over 4. But that's only between 0 and 2 pi. Add 2 pi to both of them. That's now between 0 and 4 pi. Now add 2 pi to the two newest ones. There's your full solution set for 3x. Well, if that's what 3x has to be, just divide all of that by 3. And by the way, that 21 pi over 12 can be simplified. Seven pi over 4. There's a solution set for x.
You have to check them all now?
Nope.
You didn't do any manipulation.
Right. Didn't do any manipulations. So there's no need to have to check them. I know they're going to be right. Cosine of x over 2 is 1/2. Since we're between 0 and 2 pi for x, we're going to need 0 and pi for x over 2. Where would cosine be 1/2 between 0 and pi?
Pi over 3.
So we only have one solution. X is 2 pi over 3. Sine of 2x plus cosine x equals 0. We have a problem. Sine and cosine are of different angles.
Double angle ID. Fixed.
So you have to use identification. Or identity, right? You have to use an identity. Two sine x cosine x plus cosine x is equal to 0. The cosine times 2 sine plus 1 has to be 0. Cosine is either 0, or so either cosine is 0, or sine is negative 1/2. Where's cosine equal to 0? Where else? Where is sine equal to negative 1/2?
Wait, where's the sine negative 1/2? Right.
7 pi over 6 or 11 pi over 6? All we did was use an identity. Identities don't change the solution. Our solution, that's pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6. Two cosine squared x over 2 is equal to cosine squared x. And we have a problem. They're different angles. Half angle identity for cosine. Good news. Doesn't matter if it's positive or negative. Once you square it, it becomes positive. One plus cosine is equal to cosine squared. Cosine squared minus cosine minus 1 is equal to 0. This is a polynomial we've solved already. Cosine will have to be 1 plus root 5 over 2 or 1 minus root 5 over 2.
Yeah, all right.
But we solved it when we were looking at polynomials. Because this is the golden ratio. Cosine cannot be 1 plus root 5 over 2. That's larger than 1. One minus root 5 over 2.
Cosine of that.
Is going to be between 0 and 2 pi. Really?
Wait, no, wait, wait, root 5 is. Yeah.
What's the range of inverse cosine? 0 to pi. So the inverse cosine does give you a value between 0 and 2 pi. There is another one. That's the inverse cosine. You're also going to have a quadrant 3 solution. Similar angle states that's also the inverse cosine of -3/5, or 1 minus √5/2. But we want that. No, that's simple. Just be 2 pi minus the inverse cosine. And full circle minus this bit. There's our solution set. Cosine of 2x plus cosine x plus 1 equals 0. Which one?
Cosine squared theta minus 1.
These are 2 cosine squared plus cosine has to be 0. Cosine is 0, or cosine is -1/2. Cosine 0 pi over 2 or 3 pi over 2. Cosine is -1/2. At 2π/3 or 4π/3. Solution set would be π/2, 2π/3, 4π/3, 3π/2.
What about 0?
Why would 0 be a solution?
Oh, never mind, yeah, of course.
Tangent of 2x plus 2 sine x equals 0. Do not use the double angle identity for tangent. It's going to make an unnecessary mess. Right, write it as sine over cosine. Double angle for sine. Back out 2 sine. 2 sine of x is 0, or cosine x plus cosine of 2x all over cosine of 2x is 0. Two sine of x is easy. We'll just ignore that one for now. If that fraction is 0, then just cosine x plus cosine of 2x is 0. Keeping in mind that you cannot have cosine of 2x being 0. That would mean that 2 cosine squared plus cosine minus 1 is 0. Two cosine minus 1 times cosine plus 1 is 0. That means cosine is a half, or cosine is negative 1. Which is good, by the way. We weren't allowed to have x being any multiple, or say any multiple, any odd multiple of pi over 4. Right, because that would have given us cosine of 2x being 0. Where is sine of x 0? You get 0 or pi, right? When is cosine a half? Pi over 3 or 5 pi over 3? And when is cosine negative 1? At pi. Solution set. 0, pi over 3, pi and 5 pi over 3. Sine 2x equals cosine 2x. That would mean tangent of 2x has to be 1, right? Where's tangent equal to 1? Where else? Remember, we're doing it for 2x. So those are not the only solutions.
And pi over 4, 13 pi.
Yeah, we also need 9 pi over 4 and 13 pi over 4, right? X is between 0 and 2 pi. 2x needs to be between 0 and 4 pi. That means x is pi over 8. 5 pi over 8. 9 pi over 8 or 13 pi over 8. And there's the solution set. Sine 2x equals cosine of 4x. Use the double angle on cosine to write cosine of 4x 1 minus sine squared of 2x. Two sine squared of 2x plus sine 2x minus 1 is 0. That can be factored. Right, sine of 2x is a half, or sine of 2x is negative 1. Sine is a half. Pi over 6. And 5 pi over 6. But remember, it is 2x, not x. So you also want 13 pi over 6 and 17 pi over 6. Sine is -1 at 3 pi over 2. Right? Since it's 2x, we're also going to want 7 pi over 2. X would be pi over 12, 5 pi over 12, oops, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. And again, it was just identities.